So here's a follow-up video to my earlier video on the EC1515B digital clock. In that video I commented that it seemed that I had a problem with the algorithm in the chip that was turning on some LEDs in the 60 LED circle around the periphery, that 3 of them were turning on when they shouldn't be turning on, and I assume that must be a problem with the algorithm. I decided to do some more experimenting with that, and I found something rather interesting. First off, I mapped out the schematic a little more thoroughly so I could see what was going on a little better, and it really is just a big array of bits 0 through bit 7, which are all just pins directly on the microcontroller. And then the columns are X0 through X7, so it's basically an 8x8 array, although in the last row they're not all used. And those X lines are just going through current limiting resistors and then to the P lines of the processor, which are all around here. So it's basically 8 lines in, 8 lines out, and they're multiplexing the LEDs around the periphery. And I realized that these 3 LEDs here seem to be tied to these 3 LEDs. So when these LEDs here were being turned on, they were also turning these on, but a little bit dimmer. And I really couldn't see what was causing that. It would have to be backflowing through LEDs, and they just don't work out that way. All the LEDs were working properly, and I couldn't see them being malfunctioning to the point of backflowing. And even if they were, it would cause more LEDs to malfunction than just the ones that were on. So I was kind of scratching my head there, and so I decided to scope out and see if possibly the bit 5 line that runs these and the bit 7 line that runs these might have somehow been tied together with a short. And when I pulled out the IC so I wasn't getting it in the circuit and measured with my ohm meter, I was finding that there was only about 2 ohms between these 2 lines. And I checked every other combination in here, and everything else was reading infinity, very high impedance. But between these 2 lines it was reading only about 2 ohms, which, well, no duh then. You know, if you turn one on, it's going to try to turn the other one on. And I started probing around the board in great detail with a magnifier and reheating joints and anything I could think of that would alleviate a short circuit. I just could not find a short circuit. So I decided to look around on the board where else those lines might go, and the only other 2 places where bit 5 and bit 7 are used. I should point out that the Numeric Display is also multiplexed into this same arrangement, but it's using higher bits than bit 7. It uses bits 8, 9, 10, and 11, so it's like an additional set of 4 more rows on this big matrix here. So that wouldn't be affecting it. But what I did find, curiously, is there are these 2 resistor voltage dividers here, and one of them is for the temperature thermistor. I'm not sure if it's really a thermistor, but it's some sort of variable resistance element, and that's labeled as being 50K. I don't know under what conditions, and it goes between bit 7 and bit 4, and then there's a 20K to ground. So it clearly energizes bit 7, and then that energizes this voltage divider, and then it'll read the value into bit 5 at some point in the scan. And bit 7 and bit 5 are never used in a matrix situation here, at least not in a way that would cause a problem, because there's always at least 50K between those 2 bits. That wouldn't be enough to allow any of these LEDs to energize. And then I look down here and I see, well, bit 7 and bit 5. Those are the 2 guys that are the culprits here. So I scoped it out and I took a measurement, and this is the photo cell here, and it was reading only 2 ohms across it. Well, I thought maybe that's because it's shorted out somewhere else. But if it's a short, it should be less than 2 ohms. So I pulled the photo cell off the circuit board and measured it, and here it is. And this was actually measuring, depending whether it was light or dark. In the light, it was only reading about 2 ohms, and then it went to another value when it went to the dark. So this is supposed to be a 50K part, and in reality it's only running a few ohms, so it's almost a short circuit. So this is obviously why the LED matrix was malfunctioning in that area. I'm not sure offhand why it didn't seem to be also energizing diode 56. There might have been some other reason I didn't think of for that, but definitely it was hitting these guys. And when I pulled the photocell off the board and then ran the clock, those LEDs no longer turned on improperly. However, the display went to a very dark value, and I'm going to move to the other room now and show a few more things about this. So what I've got right now is the photocells taken off the board, and I have a 100K trim pot wired in that position and adjusted to some value that's mid-range. It's probably in the ballpark of 50K, and so it's substituting for that in the circuit. So the clock is running here, and you can see that it's fairly bright. And if I mess around with the trim pot, I'm not sure which way I have to turn it here, but let me try cranking it clockwise. There we go. See how the display suddenly dimmed? And then I crank the pot around the other direction, and it comes up to a much brighter value. Go back the other way and it dims. So it appears that the clock actually has 2 brightnesses, which is full brightness and a dim brightness. Now if I turn off the room lights, the clock looks a lot better. This is obviously its nighttime mode, where all the LEDs are dimmed down quite a bit. And if I bring the pot back, simulating more light in the room, all of a sudden it goes to this much brighter mode, which is too bright for a dark room, but perfectly okay for a well lit up room. And so then I went into the mode. Let me get into the parameter mode here, and I go to parameter 10, and the light control is currently on. If I turn it off and then get back to timekeeping mode here, and I do the same experiment by cranking the trim pot around, nothing changes. The clock is no longer looking at the trim pot, or which is standing in for the photocell. Now let me turn the light sensitivity mode or light control mode back on. Turn it back on. And I'll find that sweet spot on the trim pot. There we go. So it's right around this point. And now I'm going to go back into that mode again. And I'm going to go to parameter 11, which is the sensitivity. I'm going to go to +2. And I'm back in timekeeping mode. I'm still in light control mode. And now when I change the pot through that range, it doesn't make any difference. There we go. At a much further point on the pot adjustment, the brightness came back up. So 1, 2, okay, right about there is the set point now. And if I go back into that mode, go up to parameter 11, and now I'm going to adjust it to -2, get back in the timekeeping mode. Now obviously with the setting of the pot at a -2 set point, it's going to regard the room as being bright. Now I have to turn the pot quite a lot to get it to dim off again. So because the clock was malfunctioning and lighting up some LEDs that shouldn't be lit up, in the course of troubleshooting that, I inadvertently found out how the light control mode on this works, which I didn't know before. So it doesn't have variable intensities of LED. It only has bright and dim. And then parameter 11 decides what amount of brightness is required to trigger it to go to bright mode, or dimness to cause it to go to dim mode on the display. So I thought originally that parameter 11 might be a brightness control, but what it is a sensitivity control to the photocell. And you only have one brightness when it's bright, and you can't change that. You've only got one dimness when it's dim, and you can't change that. So since I don't really care about using this at nighttime, it's going to be in my office, not my bedroom, and I don't think I'm going to bother getting another photocell. Maybe I will down the road, but I'm going to put this back in parameter mode, go up to parameter 10 and turn light control mode off, and then move up here. I'm just for good measure set this back to 0. And now we can see as it's coming around, the trouble point was when it was to get up to these LEDs up here right at the top. You can see when it gets up here now, it's no longer turning these LEDs on here. So the clock is working properly now. The only thing it's missing is it doesn't have a working photocell, a feature which I probably wasn't going to use anyway. But I thought this would be useful information to add on to my other video.